Hey everybody, welcome to the very first lesson in our 30-2 book for the year. We're starting off with a little bit of factoring review. We need to focus on some factoring because this first unit is going to depend heavily on factoring. So if you are struggling with factoring, which is okay, it's some tough stuff, I really need you to come see me as soon as you can in tutorials and get some extra help. But hopefully after we go through this, it makes a little bit more sense. Okay, here we go. So factoring, we're really going to focus on three big types of factoring in 30-2. The first couple here, we're going to be looking for greatest common factors. Then we'll look at some difference of squares, and then we will look at some very simple trinomials. So remember, what I want you to think about factoring is sort of unmultiplying. So I say to myself, what divides into 6 and 18? Well, 6 divides into 6 and 18, so I'm going to factor a 6 out. And again, if I think of that as unmultiplying, I say to myself, 6 divided by 6 is 1, so 1x. And then I say to myself, 18 divided by the 6 is 3. And I can always check my work really quickly by multiplying back in. Bingo. Next one, I can factor out a 2x. So I can factor out a 2x, which would leave me then with x minus 6. I check my work. 2x times x is 2x squared. 2x times 6 is negative 12x. Okay, next one I say to myself, what can I divide into? 3 and 9. So I can, my greatest common factor is 3. And then I say, what can I divide into x squared and x? X. So my greatest common factor would be 3x. So that's what I'm going to factor out. And again, I think of factoring as unmultiplication. So 3x squared divided by 3x is x. And minus 9x divided by 3x is minus 3. D. So my GCF, what's the smallest thing that divides into 6 and 8? Well, that's 2. I should say the biggest thing that divides into 6 and 8 is 2. And x squared and x, x. So I'm going to factor out a 2x. And then I say to myself, 6 divided by 2 is 3. X squared divided by x is x minus. Sorry, pen stopped working there for a second. Minus 8 divided by 2 is 4. Looks good. Okay, so these are all just greatest common factors. E, my greatest common factor. So what divides into 15 and 5? 5. What divides into x cubed and x? X. So I'm going to take out, I'm going to factor a 5x. And then 15 divided by 5 is 3. X cubed divided by x is x squared. Now, this I see a lot of common mistakes right here. I see just that. Remember, 5x divided by 5x is 1. Never say the word cancel. 5x divided by 5x does not cancel. 5x divided by 5x is 1. Cancel means there's nothing there. It's one of these terms that we hear when we're little guys that comes back to haunt us when we're big guys. Try to avoid saying that. F, I'm going to do something a little bit different on F. So GCF, so 3 and 9, so I'm going to take out a 3. x and x squared. I'm going to take out an x. Okay, I agree that's the same so far. But what I really want to focus on is the fact that there's a negative here. And do you see my x squared is in the back? My highest degree is the last term. I don't like that. So I'm going to do something maybe a little bit unusual here. What I want to say is I want to get my highest exponent to be out front. How am I going to do that without changing what this thing's equal to? Well, I'm going to pull a bit of a ninja move here. See how it's negative? I'm going to factor out a negative. Watch what happens. So my greatest common factor is 3x. Negative 3x though. You'll see why I'm doing that. So 3x divided by negative 3x, well, that would be negative 1. Now here comes the important part. A negative 9 divided by negative 3 is going to be positive 3, and x squared divided by x is x. Okay, big deal, you're saying. Why did he do something so crazy? Because now look at what I can do. So minus 3x, but inside my parentheses here, I'm going to reorder this to be 3x minus 1. This is a very important idea. Look at those pretty stars. This is an important idea that is going to become a big part of all of our questions coming up. Okay, so we'll practice that as we go through. It's a bit of a new idea that you've never had thrown at you before, is my guess. Okay, those are greatest common factors. These ones here are called differences of squares. So difference means I'm subtracting, and squares means I'm a square, I'm a perfect square. So what I want you to think about here is, if you remember a difference of squares, what I'm able to do is simply say to myself, okay, I'm making a square, so that means it's got to be x times x, because my side lengths have to be the same. For the 16, I'm making a square. So 16 has to be 4 times 4. I'm making a square. My side lengths have to be the same. And if you remember way back, hopefully to last year, all we do is we use different signs in between. So notice they're the exact same, but the signs in the middle are different. These are actually called conjugates. All right, let's try another difference of squares. So there's two terms, there's a minus sign in between. It's probably a difference of squares in 30-2. What has to give me x squared? Well, that's x and x. What has to give me 1? Well, 1 and 1. And then 1 will be plus and 1 will be minus. Difference of squares. So whenever I see two terms with a minus in between, that's what I'm looking for. Okay, let's try another one. There's two terms, there's a minus sign in between. This one has a 4 out front, no big deal. It's a square, so my two side lengths are 2 and 2. X and x. I'm making a square. 9 has to be 3 and 3. And then a minus and a plus to make my conjugates. Expect something like that on a test and on my diploma. J, I look at it and I go, okay, look, there's two terms and there's a minus in between. Hey, maybe that's a difference of squares. But it can't be a difference of squares because there's a cubed. What do I multiply by? Two factors that are the same to give me x cubed. I don't know. So this isn't a difference of squares. So I start looking for a greatest common factor. Oh, my greatest common factor is x. Okay. Now I say to myself, hey, what's this right here? Difference of squares. So 2x minus 1, 2x plus 1. That's a pretty tricky one, but that's where we're going in 30-2. Now we're into trinomials. Remember, there's two types of trinomials, simple and complex. Not because of whether they're easy or hard to do, but because of the answers they give us, but kind of works out that way that the simple ones are a little easier. This guy, the very first one here, is called a simple one because there's a 1 out front. So remember the game we played back in grade 10? I'd say there's two numbers that multiply to 4 and two numbers that add to 5. So I always have to think about what those two numbers are. I always have to play this little game. Well, it multiplies to 4 and adds to 5. My two numbers are 4 and 1. So now I can factor this thing. So this equals, well, x times x, because that's going to give me my x squared. And then all I have to do is take my two numbers, plus 4, plus 1. Let's try another one. Next one. I need two numbers that multiply to negative 30 add to negative 1. Well, that's going to be negative 6 and positive 5. And once I know my two numbers, remember factoring is unmultiplying. There it is. Let's try a couple more. Maybe you want to hit pause and try these. That would be a good idea too. So the next one multiplies to negative 30, adds to positive 1. So this time my two numbers will be positive 6 and negative 5. It's really easy when we start dealing with these negatives to get our signs mixed up. I would always like you to take just a quick second to see if you got your answer right. I am checking my work. I'm doing it in my head though. X times x is x squared minus 5x plus 6x, well that's going to be plus 1 minus 30. You don't see me doing it, but I am on every single question. You can trust me. Okay, next one multiplies to 30, adds to 11. Okay, so my two numbers then have to be 6 and 5. Notice I've got an equal sign going down the left-hand side because these are equal to each other. We're not changing what it's equal to, we're changing how it looks. Okay, those are simple trinomials. We don't get a lot of complex trinomials in 30-2, but they need to be done just in case. So what makes this one a complex trinomial is that there's a coefficient of 2 out front. So what I say this time is I multiply these two things together. So it multiplies to 2 times 1, which is 2, and it adds to 3. So I still have to play my little game. So my numbers here again will be 2 and 1. Now, there's all sorts of ways that teachers teach how to factor complex trinomials. I'm going to, at this point in grade 12, do something known as inspection. So I say this. Again, what I'm really doing is factoring is unmultiplying. So I say to myself, I need to get two numbers that multiply to 2x squared. Well, it's got to be an x and an x. Well, it multiplies to 2. Well, I've only got two choices, right? 2 and 1. Now, inspection says I'm going to do this. I'm going to take this guy here, I'm going to go 2. I'm going to say 2 divided by the 2 is 1. But because we're unmultiplying, I'm going to put that in the other parenthesis. And then I'm going to say 1 divided by 1 is 1. And I put that there. And if I check my work, bingo, bango, done. Try another one. So 3 times 2, so I have to multiply to 6. I have to add to negative 7. So my numbers on this one are negative 6 and negative 1. So parenthesis, parenthesis. I say to myself, what multiplies to 3x squared? Well, it has to be 3x and 1x. Now what I do is I look at my first one here, minus 6. So I'm going to go minus 6 divided by 3. Minus 6 divided by 3, minus 2. Negative 1 divided by 1, negative 1. There it is. So this is called inspection. It's a quick and easy way, once you get the hang of it, to factor a complex trinomial. If you would still prefer to do decomposition, I'll do decomposition on G. Nothing wrong with decomposition. It's actually quite handy when our numbers get big, and it will always give us the factored form. It just takes a lot more steps, but there's nothing wrong with that. Okay, so two numbers that multiply to 40 and add to negative 22 sounds like negative 20 and negative 2. So decomposition works like this. What you do is just like when something in science you've talked about starts to decompose in biology, it breaks down into its component parts. What you do is you would decompose the middle into those two, and then I put a bracket there and a bracket there, and there is a plus sign in between these. So I'm out of room, I'm going to stick a plus right there. Now I say to myself, what can I factor out of the first parenthesis? 5x, and I'm left with x minus 4, plus what can I factor out of the second set of parentheses? Well, more than just 2, negative 2. Negative 2. So I'm just going to change my plus to a negative 2. What am I left with now? X minus 4. I know I'm doing this correctly because I see x minus 4 and x minus 4. So now I'm going to factor in x minus 4 out of the whole polynomial. And what am I left with? Well, from the first term, 5x, from the second, minus 2. So that's called decomposition. It's a little longer, but hey, it gets me the answer. So if you're comfortable doing that, that's how you were taught, and you say, hey, Mr. Saliani, that's how I want to do it, and I don't care. No hair, don't care. Get the right answer, right, baby? Okay, H. First thing I want to notice on H is this is degree 3. So I don't know how to factor degree 3s, so I'm going to pull out a greatest common factor. If you take 30-1, you will learn how to factor these things algebraically in a slightly different way when they get more complex. But for us, 30-2, this is where I'm going to stop. So now what we need to do is factor this trinomial right here. So I need two numbers that multiply to negative 6, add to 3. So I say to myself, okay, what multiplies to negative 6 and adds to 3? 6 and 1, no. 3 and 2, no. Is there anything that multiplies to negative 6 and adds the positive 3? Not that I can think of. So guess what? This cannot factor. So the good news is, that's it. We're done right there. So that'll happen every once in a while. Okay, last little bit. This one says factor so the lead coefficient is positive. You've never done something like this before, but we're going to try to make this my highest exponent, my highest degree. I want that to be positive. Hey, wait a minute, we did that a few minutes ago. So what I'm going to do is I want that to be positive. So to do that, I'm going to factor out a negative 1. Well, what does that do? When I take out the negative 1, that's going to make this here have both its signs switch. So negative x will become positive x, and positive 3 will become negative 3. Why are we doing this? When we get a little bit further into the unit, what you're going to see is it's going to help us simplify a bunch of stuff down. Now, this one here, my highest exponent I see is 3, so I'm happy, that's my degree. but it's negative 15, so I want to make it positive. So I'm going to factor out a negative 5x, and negative 15 divided by negative 5 is 3, x cubed divided by x is x squared, negative 5x divided by negative 5x is plus 1. So a bit of a new step for you to try here, but you'll get the hang of it as we get into it. Next one, there's my highest degree. So it's negative 9, so I want to make it positive, so I'm going to factor out negative 3x. Negative 9 divided by negative 3 is 3x. 3x divided by negative 3x is minus 1. Okay, last one. This is actually a difference of squares. So I could right off the bat factor it like that, which is fine. That is correct. I'm not saying it's not correct. But what I want to do later on when I get deeper into the unit is that actually wouldn't help me with my work. So what I'm going to do again is notice that that's a negative x squared, so I'm going to factor out negative 1. So now the x squared is positive, and the positive 9 is negative. And now I'm going to factor that as a difference of squares. Again, I do agree that I could have factored it like that. These two are equivalent. However, you are going to want the one in the box when we get to deeper questions in this unit. Last question in our first lesson, how would you solve these equations? Wait a minute, equations? What have I been doing all along? These here that we've been working with are called expressions. They're not equal to anything. We can't solve for x because it's not equal to anything. An equation is equal to something. Now, if I look at these three I'm giving you, they're all equal to 0. An equation doesn't have to equal 0. It just has to equal something. So here's the difference. Well, I still see a trinomial, so I'm still going to factor that. And we actually factored this above, if you remember, if you go back and look. So I factor, but this time it's equal to 0. Well, in an equation, I can actually solve what I'm working with. So if you remember way back in grade 11, and you might not, that's okay. What you've got here is something known as the zero product property. This times this equals 0. Well, if something times something equals 0, what do I know about one of the numbers? It has to be 0. So therefore, x minus 6 is equal to 0, or x plus 5 is equal to 0. Now, what we can do is solve. X is equal to 6, or x is equal to negative 5. So that's a bit of a preview into where we're going to be going with these things when we start solving. It'll be important actually in our very next lesson. So take some time, try and play around with these two things and solve them. Otherwise, there is your review on factoring. If you still need some help, come see me in tutorials or send me an email, I guess. Okay, friends, that was our very first one. Hope your brains are firing up and you're remembering some math. I will see you next time.